Okay, so we're going to be um, continuing into section 11.3, talking about vertical angles and different angle relationships as we continue through this chapter about geometry. And so we have talked about um, several different angle measurements and what it means to be congruent and several things of that sort up to this point. And so now we're really going to focus on more information about angles. And so the first type of angle that we're going to talk about are what we call vertical angles. And in one of the previous videos, I mentioned vertical angles just very briefly. And so here we're going to get into a little more detail. So if you look at this diagram to the side, vertical angles are formed when two lines cross and they are, for lack of a better term, opposite of each other. So, for example, angle 1 in this example and angle 3 are considered to be vertical angles. And also, angle 4 and angle 2 are vertical angles. Now, why is that important? Well, it's going to allow us, and some things we're going to do here in a little while, to be able to find other angle measurements when we know some information about vertical angles. So all vertical angles are congruent. So for example, in this diagram, we don't know necessarily the measure of angle 1, but we know that angle 1 and angle 3 have to be the same measure. And so that should make some sense to us, because if the angle measurement from here, this side, all the way around to this side is 180 degrees, which we've talked about straight angles before, then if angle 1 has some angle measurement, we'll just call it M, and angle 4 is that 180, that full angle minus M, well, then it should make sense that if we go the other direction from here around to there, that too is 180 degrees. And so if angle 4 is 180 minus M, then angle 3 must also be M. And so we're going to see that in some examples coming up, but hopefully that will make some sense to you about why vertical angles are considered to be the same angle measurement, so they're congruent. All right, so another type of angle that we need to know about are what we call supplementary angles. These are angles that have measures that add together to be 180 degrees. Now, they can be connected, they can be adjacent to each other, or they can just be two angles that add to be 180 degrees. They do not have to necessarily be adjacent to each other. And so you see some examples here. This angle that is measured 140 degrees and this angle that's measured 40 degrees, when you add those together, you get 180. Therefore, they are supplementary. You also see in this second example, the 50 degree angle and the 130 degree angle, they are adjacent, meaning they share a side. Okay, so they share this side. And when you put them together, you can clearly see that that angle measurement, this 50 degrees and this 130 degrees, make that full 180 degree rotation. And so that is an example of supplementary angles. And so because of that, then this third diagram should be true. If that whole angle measurement from there to there, that whole rotation is a full half circle rotation, or 180 degrees, then if we know the measure of one of our angles, we'll call this one angle X. If we know that it's X degrees, then the other one can be found by taking the full 180 and taking this part away. And so it gives us 180 minus X for the other measurement. Now, I know not having numbers in that may make that a little more difficult to understand, but again, it's one of those things you've got to get your mind, you got to let your mind kind of get wrapped around this idea of angle measurements and using X as the angle measurement. Okay, so just kind of be aware of that as we move forward. The next type of angle that we're going to talk about is what we call complementary. These are angles that add to be 90 degrees. And so again, they could be adjacent or they could not be adjacent. You see the example of the 60 degree angle and 30 degree angle that add to give 90. Then you also see here in the second diagram the 70 degree angle and 20 degree angle that are adjacent because they share a side and they equal 90 degrees. And it's the same logic as the supplementary. If this angle measurement is 90 degrees, if I know the 20 degree angle, then I can take that full 90, subtract the 20, and that's going to give me this other angle. And so that's what we see here in this bottom diagram. If we know this is a 90 degree angle, because of the little box at the bottom, and we know this angle is X degrees, then this angle has to be that 90 degrees minus X, leaving us with whatever is left. This should not be here. So hopefully those three types of angles make some sense. Vertical, supplementary, complementary. And so based off of all of that, that's going to lead us to being able to work with what we call transversals. So a transversal is simply a line that intersects two other lines. And when it does, it makes this type of diagram, this first one, and it splits this region into some different parts. And so we have what we call interior angles that are the angle measurements inside those other two lines, the two that run right and left. And so angle 2 and angle 4 and angle 5 and angle 6 are all considered to be interior angles. Also, angles 1, 3, 7, and 8 are considered to be exterior angles. Those are angles that are on the outside of the transversals. Of the other two lines. The transversal is the line that is splitting those. That's this line. Okay, that's the transversal. We also have some other angles. We have what we call alternate interior angles, which would be the 5 and 2 and the 4 and 6. Those are alternate interior. And you can imagine what the alternate exterior are. Those are ones that are on the opposite sides of the transversal, but on the outside. So in this case, I'll use a different color here. Angle 3 and angle 8 are considered alternate exterior angles, and then angle 7 and angle 1 are considered to be alternate exterior angles too. And then corresponding angles are angles that are in the same location in the top as they are in the bottom. So for example, angle 1 and angle 2, so this angle and this angle, are both in the top right location. And so they're corresponding. Angle 6 and angle 8 are corresponding. They're in the same location. Same thing with 3 and 4 and 5 and 7. Now, once you identify that, and by the way, on the PowerPoint here, where this little question mark is, that should be an angle measurement like that. For some reason, it doesn't translate over in PowerPoint, so it puts a question mark there. So when you see that, when you see this little question mark in a box, that should be an angle measurement. Okay, just an angle sign. So when you see all of these, if we just have two lines separated by, or split by transversal, it forms these types of angles. Some of these angles have relationships. Some of them don't necessarily. But if our lines are parallel, line M and N in this case are parallel. If that is the case, then these angle measurements have a lot of commonalities. So angle 1 and angle 2 are corresponding, and if these lines are parallel, then those two angle measurements have to be the same. Again, we'll talk about why in just a little bit, but those two angle measurements have to be the same. Also, if angle 2 and angle 1 are the same, and angle 1 and angle 5 are vertical, and so they're the same, then angle 2 and angle 5 are the same measurement. And so alternate interior angles are congruent. You'll also notice that alternate exterior angles are also going to be congruent, because if angle 1 and 5 are vertical, and 2 and 7 are vertical, and 5 and 7 are congruent because they're corresponding, well then 1 and 7 have to also be congruent. And so there's a lot of connection between each of these and their angle measurements if the two lines are parallel, like line M and N in this case. If they're not parallel, there are some commonalities, but not as much. So most of what we